in this example, we are given a demand function for Loyola t-shirts as Q equals 1,500 minus 125p. And remember, this is reverse of some of our earlier sections where we're looking at P as a function of Q. Now we're looking at Q as a function of P. And that makes these problems a lot easier to deal with. And so the first part we're looking at P equals $5 is what we care about in this case. And for part A, we're asked about what is the revenue. And so this is actually a problem that has nothing to do with elasticity, but we're looking at revenue at $5 is going to be our price times our quantity sold. That happens no matter what. So before, we were looking at price had a fancy formula and then times quantity sold. Now it's the reverse. We're looking at our price is $5 and Q has the fancier formula. 1,500 minus 125 times, in this case, 5. And so we get 5 times 875, and we get a total for our revenue to be $43.75. So our revenue, if we have our price at $5 based on how many we'll sell, will be $4,375. Now for part B, we're asked to find what our elasticity is. And as mentioned in the discussion of elasticity, sometimes elasticity, there's a common elasticity for a product like eggs. Sometimes it depends on where you're at in your price point as far as what that elasticity actually equals. So in this case, at the price point of $5, what would our elasticity be? And what we're going to use is we're going to use the original formula. That elasticity is the absolute value of P over Q times dQ dP. And this is fancy Leibniz notation for the derivative of Q when we're using P as our variable. And we take the absolute value. So in our case, we have P is $5, Q, which we got here by plugging in to our original demand function, we get 875. So let me write that. So E, in this case, at $5, we're going to have 5 divided by 875. And then we have to look at what is the derivative of our demand function when we're thinking of Q as the output. And in this case, it would be negative 125. Because the derivative of Q with respect to P is negative 125. And we get that if we round this, we get about 0.7143. Now, for part C, they're asking if at this price point of $5, if we were to increase our price by a little bit, do we expect revenue to go up or to go down, our total revenue? And we could, by brute force, figure out by plugging in, finding what revenue looks like. And at $5, is revenue positive or negative? So is it on the increase or is it on the decrease? Or we can use the fact that we're looking at our percent change in revenue is our percent change in price times 1 minus elasticity. And if we do this, if we have an increase in price, the fact that we got elasticity right there to be about 0.7, right? So we're looking at a percent change. This is going to be positive times 1 minus 0.7143. So we have a positive times a positive, that means our percent change in revenue is increasing. So it's overall positive. So we have revenue would increase. The other way of doing it is to figure out revenue based on price would be 1,500 minus 125p times p. And when we figure this out at $5, whoops, we need to find the derivative first. 1,500p minus 125p squared. So our derivative of revenue would be 1,500 minus 250p. And at a price point of $5, we get that it is $2.50. Again, the key is not the actual number, but the fact that it was positive. So the derivative right at that spot of revenue, that price point of $5, the revenue is positive, revenue is increasing, so we should probably increase our price point.